Welcome back, everyone. In this video, I'm just going to be giving a quick refresher on sigma or summation notation. So it's called a refresher because usually in a calculus class, you should have been exposed to this. If this looks completely new to you, then really what we're going over should be enough. Usually in like a pre-calculus class, you go over a lot more than what we're going to talk about. I'm just going to talk about really what we need. So the first thing about sigma notation refresher is it's really about being able to write something if you have a pattern of adding stuff together in an easy way. So let's say we wanted to add 1 plus 2 plus 3 plus 4 plus 5 plus 6. Let's just go up to 8. Well, that took me a while to write. And what if you were posed with the question, I want to add up 1 to 100 like this. So I want to go all the way to 100 or 1,000. Well, I'm not going to write on your paper 1 plus 2 plus 3 all the way up to 100. I'm going to use what is called sigma notation. And sigma notation, you start with something called an index. We usually use I. You start with the number that begins here. And what you'll see when I go through and do the next example is it's not necessarily the number here. It's pretty much always just 1. Very rarely will you start with anything else. You sometimes could start with 0, but almost always, all right, almost in quotes, always start with 1. But let me go ahead and just leave that 1 like I normally write it to avoid confusion. But this I is just called the index. Now you can use any letter. The common letters is I and J, sometimes K for index. But what we do is we have a starting value. Then if you start with 1, then the number of things you're adding together. So number of terms added together. This is really the top value that goes here. Now you just want to count the number of things you're adding together. 1, 2, we know this is 8 because I started from 1, but you would just count the number of things that are being added together. We have 1, 2, 3, 4, 5, 6, 7, and 8. And that goes on top here. Now, once again, I'll do a very quick example after this just to show you how you always start with 1, and this may not match the number here, and that's fine. And then what you put inside is you put basically the formula for, or the pattern of what's going on here. So this is I equals 1. This is at I equals 2. This is the I equals 3 term. It's sort of like a pattern, just like you do with sequences, if you're familiar with those. It's sort of like pattern recognition. Well, this pattern is super simple because every time we increase 1 by I, so that's going to be the thing is these i's are whole numbers. It starts with 1, goes to 2, then 3, then 4, then so on, up to 8. Well, for this one specifically, I equals the number up here. So we have I equals the number right there, which is why I put I inside here. Right. So that's really the basic setup. What I want to go ahead and do is just do a problem where everything's not perfect here, just to really enforce it back. Now, it's not a huge deal to really be able to go from this side to this side. You want to more so be able to go from this side back over here. But I think, when you understand this way from left to right, it's better for understanding right to left. All right, so I'm not going to do so many things here. Let's just add up 4 things. And let me come up with a quick example here. Let's say we start at 0, and then we got plus 3, plus 8, and then plus 15. Now this is not an obvious pattern, so I wouldn't really expect you to be able to find the formula. But what is going to go on this sigma notation? Well, the index pretty much always starts at 1. And the top number is the number of things we're adding together, which is 4. All right, now the thing that goes in here, I'm going to go ahead and write down it's I squared minus 1. But I want to go ahead and explain why this is I squared minus 1. Once again, it's you're more interested in going from this way back here. So if you're giving this can you tell me it's 0 plus 3 plus 8 plus 15? And then can you add it together? Well, that part's the easier part to give me the answer. So we see I squared minus 1. Well, this is with I equals 1. This is I equals 2. This is I equals 3. And this is I equals 4. So once again, you always start at 0, or sorry, at 1, unless if you're specified something else here. This is the starting I value. This is the ending I value. And you just increase by 1 every time. Well, 0 is definitely 1 squared minus 1 because that is I is 1. Is 3 equal to 2 squared minus 1? Yes. Is 8 equal to 3 squared minus 1? Yes. Is 15 equal to 4 squared minus 1? Yes. So really that's the main thing about sigma notation is kind of what's happening here. There is one really important useful property, and it really comes into play when we do some problems later on in this section, the section that we're about to do. There are more than one property, but this is mainly the useful one, is that if you have to do the sum from I equals 1, it doesn't matter what it is. You can actually just say it's n because we don't know what it is. The index is our variable. So it's like an f of x. It's like a x and an f of x. The index is our variable. So the index is I. What that means here is that, let me go ahead and write down a kind of a weird formula. Let's say we have I squared times the sine of I. We don't want to actually try to find the sum here, over n squared plus 1. All right, so I intentionally chose n to match this in, but the point here is that the index is I. So what happens with here is that everything with I must stay inside. It's sort of like when you think about what we're doing over here, we want to plug in I equals 1 and add, plug in I equals 2, add, plug in I equals 3, add. But as we're plugging in, the n squared over 1 is just staying in the denominator every time. So let's just go ahead and write down a couple terms here. So when we plug in I equals 1, we get 1 squared times sine of 1 over n squared plus 1. Remember, we're only plugging in I, so we're not plugging in n, plus. Then when we plug in I equals 2, we get 2 squared times sine of 2 over n squared plus 1. And then I'll just write down one more, but this would go on until we eventually hit whatever n is. So we get 3 squared times sine of 3 over n squared plus 1 plus ... however many we have. But because this n squared over 1, or n squared plus 1 is never changing, you can factor it out. And it's in the denominator. So when you factor out, it's 1 over n squared plus 1 when you factor it out. Then you're left with all the numerators. So when we take this out of the denominator, we have 1 squared times sine of 1 plus 2 squared times sine of 2 plus 3 squared times sine of 3 plus however many there is. And if you rewrite this back in summation notation, what's happening here is you're not really adding the n squared plus 1 in every term, it's just out front. 1 over n squared plus 1. What's being added here is this. So you have the sum of I equals 1 to n of I squared times sine of I. And the point here is that what you'll notice is that the stuff with I ended up staying inside the summation. But the stuff without I, which was that n squared plus 1, it didn't matter that n is up here because it's not I. You can bring it out. So we can bring out anything without I as long as it is not attached by a plus or minus to an I. And the reason why you can't bring it out if it's attached is I'll just go ahead and say here, if this was like plus n, then all of these would be plus n. Well, we can't factor out a plus n because we know how to deal with fractions and factoring and everything pretty well. We would only be able to factor this in out if it was multiplying it, because then we could just exactly that. That's what it's needed for factoring out. So anything that's attached to something with an I with a plus or minus, you can't factor out, which means it stays inside as well. But as long as it's not attached to an I in any way, as far as plus or minus, then you can bring it out. And that's going to be a very important property when we do a problem in the lecture. So I wanted to go ahead and mention it. Otherwise, really just understand when I say index, I'm talking about the letter here. Understand really, more importantly, how to go from the right side to the left side, but I wanted to talk about it both ways, and then you should be fine for this refresher. The only other thing is that I have these useful summation formulas that you do not have to memorize. So they'll be given to you if you need it, or you can just look them up. But they'll be right here in the notes for you. And they're just helpful for common summations we might find in this section. So I just wanted to make you aware of that, and I'll see you in the next video.